Hello everyone, in this video we will cover review test 3. The first question is from section 8.2. So this is from section 8.2. In this question, it's asking you to test the claim to see if mu is 20A against mu is not 20A. This is the given information. It tells you the sample mean is 16, the sample variance is 4, sample size is 16, and and alpha is 0.01. So step 1 is already given. So let's go to step 2. In step 2, remember you had to find T star, and T star is equals to the square root of n times x bar minus mu over sigma. In our case, this is the square root of 16 times 16 minus 20a over 4, which gives you negative 12. Then step 3, you need to find the rejection region. Remember that this is a two-tails test, so alpha has to be divided by 2. Since we're using T, the rejection region is going to involve T. So the rejection region will be plus or minus T of alpha over 2, which is 0.005. And recall that the degrees of freedom is n minus 1, which will be 15. You look to the T table, this is plus or minus 2.947. The other rejection region, remember, it's required that you draw the rejection region. Have 0 here, 2.947, negative 2.947. The rejection region is here and here. So this is the rejection region, this part 2. Okay, next, remember you have to look for T star and check if it is in the rejection region, which will be here, or in the fail to reject area. In our case, T star is negative 12, which is clearly in the rejection region. So then for step 4, for the conclusion, is to reject HO, which implies mu is not equals to 20A. In this case, there is not much to explain, just that you have enough evidence to show that the mean is different from 28, and that's it, from 28. Now let's look to the p-value method. For the p-value method, p-value, remember that step 1 and step 2 are the same. So step 3, remember there is 2 ways to find step 3, with the calculator or with the table. If we use the calculator, the p-value will be twice the probability that T is greater than the absolute value negative 12, which is just greater than 12. If we use the calculator, this will be 2 TCDF. 12 is the lower bound, 1000 the upper bound, and 15 the degrees of freedom, which is around 4.0 3227 e to the negative 9, which means you have 8 zeros, and then the number 43. Well, clearly, in step 4, the p-value is less than alpha, and remember the p-value is less than alpha, which was alpha 0.01. Remember the p-value is less than alpha, that means reject HO. You don't have a calculator, remember you can approximate this using the t-table. So you look to the table, the number 12 is bigger than the last value in the table, and remember that the area, as you move farther to the right, the area keeps getting smaller. The number gets bigger, but the area gets smaller. So the p-value, you look to the last value in the table, the last value in the table is 0.005. So all you have to do is pick something smaller than that, like 0.001. This will give you the exact same result because this is still less than alpha, which is 0.01. So the conclusion is still the same, reject HO. Number 2, this question is from section 8.3. It says Mr. claims that at least 60% of female car owners have a hybrid car. So the claim, remember, always has to have the equal sign. So for step 1, HO, the claim is that the proportion is 0.6, even though he's claiming that it's at least 60%. In order to figure out the alternative, we need to look to the information we have. Here, N is 100 and X is 58, because 58 people say that they own hybrid cars. From here, P hat is 58, 100, which is 0.58, and is less than what Mr. Clean is claiming, so this should be less. So that's how you figure out the alternative hypothesis. In step 2, you need to find something with a star. In this case is C star, or the test statistic. Remember the formula is P hat minus P over the square root of P 1 minus P over N. If we plug in the values we have, this is 0.58 minus 0.60 over the square root of 0.6 times 0.4 over 100, and this is around negative 0.41. In step 3, we need to find the rejection region. Because of this, remember this is a one-tail test, so alpha doesn't have to be divided by 2. Actually, alpha is not even given, so by default, remember that if there is no alpha, by default alpha is 0.05. So the rejection region, since the alternative is pointing to the left side, the rejection region has to be also on the left side. So in this case, the rejection region will be minus C of alpha, which would be minus C of 0.05, and these values are in the formula sheet. We have done this many times, so that's the rejection region. Remember that you have to draw the rejection region, and that this question is one-tail, so the rejection region is only on the left side. So in this particular case, this is the rejection region. Now, is C star in the rejection region or not? Not really. C star is negative 0.41, which is not in the rejection region. So the conclusion is fail to reject HO, which implies the P is equals to 0.6. Remember that this pretty much means that there is not enough evidence to reject Mr. Klein's claim. It doesn't mean he's completely right, it just means you don't have enough evidence to reject his claim. Okay, so now let's look to the p-value method. For the p-value, remember step 1 and step 2 are the same. For step 3, the p-value is the probability that C is less than C star, which is the probability that C is less than negative 0.41. At this point you have two choices. You can use the calculator or you can use the normal table to figure this out. So in this case you have minus 0.41, and whatever this area is, this will be the p value. If we use a calculator, this is normal CDF. The lower bound is minus 1000 and the upper bound is minus 0.41, and this is around 0.34. You round it to 2 decimal places. Remember, the last step is always to compare the p-value, which in our case is 0.34, with alpha, which is 0.05. So this is greater, and that means fail to reject HO, and there is no need to explain twice. Number 3 is from section 8.4. Here the claim is about the standard deviation. So step 1, the claim is that the standard deviation for the height of the recruits is phi. So the standard deviation is equals to phi. That's the claim. We still need to figure out the alternative. So in this case, we're gonna do this question 2 tails, because that's how it's gonna be asked on the test. So this will be not equals to phi. The information that we have is n is 20, as the sample standard deviation is 7, and alpha is 0.01. So in step 2, we need to find the test statistic. So chi squared is n minus 1 s squared, or sigma squared. So in this case, n is 20, so 20 minus 1 is 19, s is 7, so this is 7 squared, and sigma is 5, so it's 5 squared. And this is around 39.2. Step 3, remember you always need to find the rejection region. This is 2 tails, so you have to find the right and the left side. Remember that chi squared is not symmetric, so you need to be careful with that. So first you need to figure out chi squared right, which is chi squared of alpha divided by 2, and then the degrees of freedom is n minus 1, which is 38.582. We also need chi-square left, which is chi-square of 0.99519, and this is 6.844. Remember that these two had to add to 1. That's the connection between the right and the left. Okay, next you have to draw the rejection region. Remember that this is not symmetric, so this starts in 0, so you have to be careful with the left side. So the left side is this one, the right side is 38.582. So the rejection region is here and here. If it is in any of these two areas, you have to reject it. If it is in the white area, this one will be failed to reject. Okay, so now chi-square star is in the rejection region, barely, but it's there. So chi-square star is 39.2. It's on the rejection region. So the conclusion is to reject HO. So step 4 is reject HO, which means you have to accept the alternative, which in this case it means sigma is not equals to 5. So that implies that there isn't, or there is not enough evidence to support the recruiter's claim. The recruiter's claim about the height. That should be enough. Okay, what about the p-value? Remember that for the p-value method, it's the same story as before. Step 1 and step 2 are the same. So for step 3, the p-value will be twice the probability that chi-square is greater than chi-square star. So it will be twice the probability that chi-square is greater than 39.2. Again, you have two choices. You can use the calculator or the table. So this is 2 times chi-square CDF. The lower bound is 39.2, upper bound is 1000, and the degrees of freedom is n minus 1, which is 20 minus 1, or 19, and this is around 0.008. Remember, the last step is to compare the p-value with alpha, which in our case is 0.01. This is clearly less, and that means again to reject HO. Remember, you use the table. You have to find a value in between the table. You use the table. The last two values on the table are 38.582. This area is 0.005. The previous value was 36.191. The area to the right is 0.10. As you can see, when the number gets bigger, the area to the right gets smaller. Since 39 is somewhere here, all you have to do is pick something less than 0.005. So you could pick like 0.001, but anything smaller than this will still give you the same conclusion. In our case, the calculator gives you the precise value, but you don't need to have the precise value. If you pick, let's say, the p-value from the tables around 0.001, this is still going to be less than um, 0, 1. So that still will give you the exact same conclusion, which is to reject HO. Question number 4 is from section 9.2. The claim is to check if two proportions are the same or if there is a difference between two proportions. This problem requires 6 data points of information. You only have 4. You need to find 2 more. You are missing P1 hat, and to find that, this is x1 over n1. It's 200 over 400, which is 0.5. Also, you are missing x2, so to find x2, this will be P2 hat times n, or 500 times 0.7, which is 350. Once you get all the information, you can find P bar, which is x1 plus x2 over n1 plus n2. If we plug in the values, we'll have 200 plus 350 over 400 plus 500, which is 0.61. You round it to decimal places. Once you get all this information, then you can plug it into the formula, or you can use the calculator, the I-83 or 84, to find the value of C star. You don't want to go through the whole computation. But if you do, this is how you find step 2. C star is equals to 0.7 minus 0.5 over the square root of 0.61 times 0.39, 1 over 400, 1 over 500, take the square root. This is around negative 6.12. Again, you don't want to go through all of this pain to find C star. You can just use the calculator. You have to go to Stat, Test, and then look for the one that says two proportions, C test, and it will give you this value. Okay, now step 3, to find the rejection region. Remember, there is a two-tailed test. Alpha is not given here, so that means alpha is 0.05 or 5%. So the rejection region is plus or minus 0.025, because alpha has to be divided by 2. This is equals to plus or minus 1.96. Draw the rejection region, just like we did in all the other problems. Make sure you shade the rejection region. So if you are here, you reject. If it is here, you also reject. Okay, the value for C star is minus 6.112, which is definitely in the rejection region. So the conclusion is reject HO, which implies P1 is not equals to P2, which implies that there is a difference in the proportions. Since there is no context in this problem, this is enough for the explanation. Okay, so now let's go to the p-value. For the p-value, remember that step 1 and step 2 are the same. So you only have to worry about step 3, step 4. Step 3, the p-value will be twice, because it's 2 tails, the probability that C is greater than the absolute value C star, or 2 That's the probability that C is greater than 6.12. If you use the calculator, this will be 2 normal CDF 612,1000. Which will give you a pretty small number. Okay, question number 5. This is from section 9.1. Here you're gonna test to say if there is a difference between two means. Here we have x1 bar equals to 12, s1 equals to 3, x2 bar is equals to 10, s2 is equals to 4, n1 is equals to 20, and n2 is equals to 24. The first step is to figure out what is the claim. And here, remember that regardless of what the question says, you're going to test whether there is a difference or not. So the claim is that there is no difference. This means there is no difference between Apple and Google. And if you reject HO, that means there is a difference. Okay. So now step 2, you need to find the test statistic or T star, and T star is equals to x1 bar minus x2 bar divided by the square root of s1 square over n1 plus s2 square over n2, which gives you 12 minus 10 over the square root of 3 square over 20 plus 4 square over 24. And this is around 1.89. Again, if you have a TI 83 or 84 and you don't want to go to this trouble, you can go to Stat, Test, and then look for the 2 sample t-test, and it will give you T star. Otherwise, you can just use the formula the way we did. Okay, in step 3, we're going to find the rejection region. So the rejection region, it will be plus or minus because it's 2 tails at t of 0.025. Again, alpha is not given, so by default it's 0.05. The degrees of freedom is the smallest n. The smallest n is 20 minus 1. The degrees of freedom is 19. Well, this is 20 minus 1. Then if we look to the t-table, this will be plus or minus 2.093. Right, remember you always have to draw the rejection region. So this is 2.093, negative 2.093. Make sure to shade the rejection region. And then is T star in the rejection region. In this case is not. T star is 1.89, which is not in the rejection region. So the conclusion, therefore, is fail to reject HO, which means there is no difference between Apple and Google, or between the iPhone and the Google phone. So this implies that there isn't, or there is not, enough evidence to support Apple's claim that the battery in the iPhone lasts longer than the Google phone. Okay, now let's do the p-value method. And by now you know that step 1, step 2 are the same, so let's jump to step 3. The p-value will be twice the probability that t is greater than t star, which is 1.89. If we use the calculator, this is TCDF, 1.89, that's the lower bound, 1000 is the upper bound, and 19 is the degrees of freedom. Just in case you forget, remember that to find this one, you had to do in the calculator second variables, and then just look for TCDF. Remember, you can also approximate this with a calculator, with a table. I'll show you in a little bit. So once you use the calculator, this is around 0.07. The last step is to compare the p-value with alpha. Clearly 0.07 is greater than alpha. So again, that implies fail to reject HO, which kind of means accept, but that's not completely true. Now, you don't have a TI 83 or 84, you can use the t-table. You look to the t-table, just look under the degrees of freedom, which it is 19. The number you're trying to find is 1.89. That value is between two numbers, 2.093 and 1.729. If we look to the table, these are the values we got. So all you have to do is pick something between 0.025 and 0.050 and then multiply times 2. You can pick whatever you want between those two values. So the p-value will be around twice 0.03, which is between these two, or 30. So this is around 0.06. If you compare that, still will be greater than alpha, and the conclusion will be the same. Okay, that's it. Okay, question number 6 is from section 10.1 and 10.2 combined. There's actually a typo on this one. You could do the problem with this information, but this value is supposed to be actually 20.8. If you did it with the other number, it's fine. On the test, whatever values you have, just use those values. Okay, so R, remember, is equals to S of xy divided by the square root of S of x times S of y. So this will be 20.8 divided by the square root of 24.8 times 20.8, which is around 0.92. You round to 2 decimal places. For the part B and part C, we're going to need to know what is x bar and also y bar. X bar is 14 divided by 5, which is 2.8, and y bar will be 34 divided by 5. Remember, here the value for n is 5 because you have 5 points, 1, 2, 3, 4. 5, and this is around 6.8. Okay, so this is the correlation, which remember has to be between -1 and 1. Y half requires that you find M and B. M, remember, is equals to S of xy over S of xx. So this is 20.8 divided by 24.8, which is around 0.84. Now B is equals to y bar minus mx bar. So then this will be 6.8 minus m, which is the value we just found, times x bar, which is 2.8, and this is equals 4.4. Hence the equation of S fed will be y hat equals to 0.84x plus 4.4. So this is the equation that you need here to predict the value. So y hat, which is the same thing as predict y, it will be 0.84 times 4 plus 4.4, and this is around 7.76. Finally, we need to test the hypothesis, which is given right here. They give you step 1. Step 1 is saying is the correlation is 0. The alternative, the correlation is not equals to 0. So if you fail to reject, that means there is no correlation. And if you reject HO, that means that there is a correlation between X and Y. Okay, so for step 2, define T star, which is R, n minus 2, 1 minus R squared. We already found R in part A, so this will be 0.92, the square root of 3 over 1 minus 0.92 squared. This is around 4.06, or you can just round it to 4.1. Okay, so then step 3, we need to find the rejection region. This is T, so it's the same T that we did in 9.1, 9.3, so in chapter A. So the rejection region will be plus or minus T of 0.05, because it's alpha divided by 2. The degrees of freedom, this is the only one where the degrees of freedom is n minus 2, which is 5, and it's right there. This is 3, so this gives you plus or minus 3.182. Draw the rejection region. In this question, you can do either the rejection region or the p-value. It's up to you. This is 3.182, negative 3.182. T star is 4.1, which is definitely in the rejection region. So therefore the conclusion will be to reject HO, which implies rho is not equals to 0, which implies that there is a correlation between X and Y. And that's it. Question 7 is from section 9.4. The claim given, or step 1, we're trying to check if the two standard deviations are the same or if there is a difference between the standard deviation. And step 2, need to find the test statistic, which in this case is F star. Remember, we had to pick the biggest S to be the numerator. The biggest S is 20. So therefore, S star is going to be 20 squared over 15 squared, which is around 1.78. Now, before we find the rejection region, the degrees of freedom for the numerator and the degrees of freedom for the denominator has to be found. Remember, this depends on the biggest S. So the biggest S is 2, so therefore this will be the numerator. So the degrees of freedom for the numerator is going to be 7 minus 1, which will give you 6. And the denominator will be 9 minus 1, which will give you 8. So therefore, when we find the rejection region, we can find F right, or the right side. You cannot find the left side with the table, so you had to stick just to the right side. Alpha is not given, so that means alpha is 0.05. This is a two-tailed test, so you have to divide alpha by 2, so this is 0.025. The degrees of freedom for the numerator is 6, then A. So you look to the table, this is around 4.65. Draw the rejection region. Remember that F, just like chi-square, is not symmetric and starts in 0. In this case, the rejection region is 4.65, so anything in here will be rejected. F star happens to be 1.7a, which is not in the rejection region. So the conclusion is fail to reject HO, which implies sigma 1 is equals to sigma 2, or no difference between the two, or that you don't have enough evidence to show that there is a difference. Okay, you can use the p-value too, and again you have two choices. You can use the calculator or you can use the table. For the p-value, just remember step 1, step 2 are the same as before. Now for step 3, the p-value is twice the probability that f is greater than f star, which in this case is 1.7a. So this is 2 FCDF 1.7a 1000, the numerator, the denominator, and this is around 0.44. Okay, remember the last step is to compare the p-value, which is 0.44, with alpha, which is 0.05. So clearly this is bigger. Remember, p-value bigger than alpha implies fail to reject HO. If you don't have a calculator, you can also use the table and you can approximate the values. Remember that for the F table, the alpha values are on the left side. The numerator goes this way, the denominator goes this way, and you have 5 values. All you have to do is find 1.7a has to be between one of these values. In this case, 1.7a is bigger than the first value, so that's why you have to pick something bigger than 0.1. So if that was the case, since the value is on the top, somewhere here, you can say the p-value is 2 times 0.1, which will give you 0.2, which is definitely bigger than alpha, and you will get the exact same conclusion. Question number 8 is from section 9.3. In this example, we have two dependent samples. You have 5 students that took the placement test, and they scored into developmental math. So X1 is the before, or the first results they got on the test. After that, they went to a boot camp for 2 weeks. They take the test again, and you want to know if there is an improvement, and that's what we call after. So here D is after minus before, or before minus after. It doesn't matter. If there is no difference, these two will be the same, so you will get 0, and hence step 1 is this: mu D equals to 0, which means there was no difference between the original test and the second test. But if you reject that, that means this is not equals to 0, and that means that there is a difference. This question is very similar to section 8.2, so the process is actually identical, except that this is dealing with two dependent samples. For step 2, T star is the square root of n times D bar over S D. Here n is 5, D bar is 21.8, and this is 19.3. This is around 2.48. Okay, so step 3, same story as before. The rejection region. This is 2 tails, so it's going to be plus or minus T of alpha over 2 degrees of freedom, which would be plus or minus T of 0.05 with 4 degrees of 0.25 with 4 degrees of freedom, and this is plus or minus 2.776. Again, draw the rejection region just like all the previous problems. This is 2.776, 2.76. This and this is the rejection region. Alright, so in this case, this stat is 2.48, which is not in the rejection region. Close, but it's not there. So therefore, the conclusion is fail to reject HO, which implies mu D is equals to 0. So that implies there is no difference between before and after, which implies the 2 weeks have no influence, or the 2 weeks didn't help. We also have the p-value, and just like all the other times, the p-value is going to be twice the probability that T is greater than T star. T star is 2.48. This is twice TCDF, 2.48, 1000, and 4 degrees of freedom. And then whenever you compare this, the p-value is going to be greater than alpha. Okay, so you can finish that. later. Question 9 is from section 10.3, and in this section we're trying to check if the row variables, which are these two, are independent of the column variables. Hence, step 1 is HO are row and column variables independent, and the alternative is the row and column variables are dependent. So that's the claim. Now step 2 is the part that takes a little bit of time. You can use the calculator and you don't want to go through all the pain. But here, the 70, or the number outside the parentheses, is the observed value, and the number in the parentheses will be the expected value. So in our case, this will be 66 minus 70 squared over 66. Remember that the formula is the sum of O minus E squared over E, or you can change this to E minus O. It doesn't matter. Plus 66 minus 65 squared over 66 plus 66 minus 62 squared over 66, and so forth until we get to the last one, which is 34 minus 38 squared over 34, and this happens to be around 1.47. Then, same as before, step 3, need to find the rejection region. This is a one-tailed test, which means you have to use alpha, not alpha over 2. So the rejection region will be chi-squared of 0.01. Remember, to find the degrees of freedom, it will be the number of rows minus 1 times the number of columns minus 1. So in our case, this is 2 minus 1 times 3 minus 1, which is 2. So the degrees of freedom is 2. So the rejection region is this. If you look to the chi-square table, this is 9.20. Remember, the chi-square is now symmetric, so you have to watch out for that. This is a one-tailed test, which means you only need the right side. So technically, this is chi-square right. So the rejection region is 9.210. So any number in here will be rejected. Our chi-square star happens to be 1.47, which is clearly not in the rejection region. So the conclusion is fail to reject HO, which implies row and column variables are independent. And what is the explanation here? Well, you don't have enough evidence to reject that they are independent. Okay. Now, what about the p-value method? For the p-value, remember that step 1, step 2, was like all of the problems, it's the same. The p-value, this is a one-tailed test, so it's the probability that chi-square is greater than 1.47. You use a calculator. This is chi-square CDF 1.47 1000, and then the degrees of freedom, once the degrees of freedom is 2, this is around 0.48. The last step is to compare the p-value with alpha. This is clearly bigger, which means again fail to reject. You can also use the table and approximate the value just the way, or in the same way we use the t-table or the chi-square table before. So we'll give you the exact same answer.